Hi guys, just as promised, I'm going to go over a problem that concerns the displacement, average velocity, and so forth type of problem that you're going to see in your homework or just in general when you're dealing with calculus. So let's look at number 13. See if I can kind of get a nice little focus on that. Okay, so a rock is thrown vertically, and you have the answers right here, but it's not going to really matter much if you don't know how to attain these answers. So I really don't mind that the answers are just written right there. A rock is thrown vertically upward from the surface of the moon at a velocity of 24 meters per second. So don't worry about 86 kilometers an hour. And it reaches a height of s, which is equal to 24t minus 0.t squared meters in t seconds. So what this is basically saying is that t is your independent variable. So it's everything is with respect to t. Okay. S as we just so you can kind of see why I wrote my notes that weird way instead of saying S is speed. S is position. This is let me see if I can kind of write this down here. So imagine the rock being thrown up in the air, right? And it comes back down naturally, right? So S is just a position. S is where is that rock at t. So t is the time in seconds, and exactly where is the rock? Is it here? Is it here? Or is it here? Or is it at the top? Or where is it? Okay. And then that actually has, so this is a position. This is position. And the actual equation that we see is it's a function of time. So 24t minus 0.8 t squared. This is in meters. Your answer, whatever you plug in your time, at what time, so it could be 2 seconds, 3 seconds, 4 seconds, the answer should come out as meters when we're talking about position. Okay, so you put in seconds in here, and then you see what comes out, and then that's what the amount of meters. Like at what meters? At what meter were we at? 2 meters, 3 meters, 4 meters, 5 meters, 6 meters, 7 meters. What amount of meters are we at? Like at what? Like the height. So basically s, or like a s. Like at what position? Like in height. Like here, 1 meter, 2 meter, 3 meter, and so forth. Okay. Find the rock's velocity and acceleration as functions of time. The acceleration in this case is the acceleration of gravity on the moon, blah, blah, blah. All we really need to know is can you take the derivative of this guy? So for number one, or for A, basically, again, we know that S is equal to 24t minus 0.8 t squared. Hopefully from your last video, you will remember that if you get velocity, with respect to time. That's the same thing as taking the derivative of your position. This is not speed, this is position function. So how you do that is you do the power rule. So 24t to the first power. Basically, this just becomes 24, and then you subtract 1 away from t, and that or 1 away from the exponent next to t, which makes that just t to the 0, t to the power of 1, 0. I'm sorry, which would just be 1. So anything to the exponent of 0 would be 1. So it's just 24 times 1, really. Minus, and then you do the power rule here where you plug down 2 down here. That's 0.8 times 2 now. T, and then it's 2 minus 1, which is just 1. So it's going to be 24 minus 1.6 t. That is the equation for velocity. And then to find acceleration, that's simply dv of dt, or simply put, the second derivative of your position function. It's written like this. I know the 2's are in weird positions, but just trust me, that's just how it is. So you take the derivative of 24, which is a constant, that's just 0, and then the derivative 1.6t would just be minus 1.6. So that would just be 1.6. If you're wondering about the units, position is in meters. Velocity is the instantaneous change of meters per unit of time, which is seconds. So that's meters per second. And this would be meters per second squared for acceleration. Okay? Because if you think about it, this was taking, so this was position, the change, the delta, the change in position over time, over a change in time, right? So that would literally be a change in meters per change of seconds, right? And this acceleration is the change of velocity. So it's the change of velocity divided by the change in time. I guess we didn't really go over this last video, so I do apologize. And that was the change in meters per second, right? Because again, velocity was position over time and meters per over seconds. This is the change in meters per second divided by seconds, change in seconds. So that gives me meters per second squared. Okay, so that's it for A. You didn't have to do all this stuff here. You didn't have to do that, but you did have to do this work. And ultimately, let's just check our answers. Velocity was 24 minus 1.6 t meters per second. Oh, even has a unit. And acceleration is negative 1.6 meters per second squared. Okay? How long did it take the rock to reach its highest point? Okay, so let's check it out. So the question is, how are we going to find its highest point? Well, position really is not going to help me, because how am I going to find where position is like at its highest? I don't know what the highest position number is. I don't even know how high this thing goes. I just know that there's an equation to plug in different times, right? Like I can put in 1 second, 2 second, 3 second, 4 second. It'll spit out how high it goes. So theoretically I just put in every single second there is in here and just find out what the highest value of S is. In fact, if you want, you can put that in your calculator, your graphing calculator, do that. Okay, so that's one technique, but I think that's really tedious to do. So instead, think of it this way. As this person throws it, right? That person throws it. Oh, he's got his little mouth here, and he just threw it with his hand right there. He just throws it in the air. Okay, you can kind of see that the velocity and acceleration are going up, and steadily right here. If you think about it, what is the velocity right up here when it's like just stops, goes down? Remember, I said that it stops, so you can kind of think of it as this. The velocity is 0 right there. Okay, the velocity is there's no speed because it just stops and it goes back down. So the velocity changes as it goes down. Okay, same with the acceleration. It accelerates, and all of a sudden the acceleration just stops and then it goes down. Okay, so what I'm going to do for B is set v of t equal to 0. And then I'm going to take my actual equation for v of t. There is an actual equation, which is 24 minus 1.6t is equal to 0. Let's just solve for t. What value of t will make this whole thing equal to 0? Well, how do you solve for that? You just use algebra. It's nothing actually that fancy. You just add 1.6 to both sides, 1.6t technically. 24 is equal to 1.6t. You divide both sides by 1.6 to leave t by itself to see what the value of t would be. And you're going to find out in your calculator that is 15 seconds. Okay, so there you go. At 15 seconds, after this person throws the rock at the moon, on the moon or whatever, after 15 seconds have elapsed and it being in the air, it finally reaches its peak and then it steadily falls down. Okay, that's how you solve for that. Let's see if I did that right. Oh, look at that, 15 seconds. Well, the next question is, how high did the rock go? I don't know. How high did it go? Well, will this help me give me an answer? And if I ask you how high is it, then you got to think the answer is going to be in meters, right? If I say how high did the rock go? 15 meters per second. That's not what I asked. I didn't ask for velocity. I'm asking how high was the rock at 15 seconds? Negative 1.6 meters per second squared. Okay, that doesn't make any sense. So, logically speaking, this equation, not velocity, not acceleration, but position, should give me an answer in meters that makes sense. If I ask at 15 seconds, how high is the rock? it should be at something meters, right? My answer will come out as meters. So that means I'm going to take 15 seconds, which is a time t. I can just plug it straight into this equation, can't I, to find out an answer in meters, okay? So let's do that. So S is equal to 24t minus 0.8t squared. And I know that at its highest point, it's at 15 seconds because the velocity is 0 there. Okay, so I'll just plug in 15 seconds. 24 times 15 minus 0.8 times 15 squared. Okay, I'm not going to go through too much of the math, but you should be able to get 180 meters. So it's not bad. Well, I mean, the person's on the moon, but he throws the rock in the air. After 15 seconds, it gets up to 180 meters. Let's take a look at that. Oh, look at that, 180 meters. When did the rock reach half its maximum height? Okay, let's be creative here. Okay, so let's see here. Well, at 180 meters, right? What is half of that? That's basically 180 is equal to, divided by 2 is 90. So let's say that S is equal to 90, and now we don't know what T is. Well, it's pretty simple. It's not simple, I'm sorry. The doing it is simple, but trying to figure it out on your own is not, okay? That's why I'm here, to try to help you as best I can. We're going to take S is equal to 90, and then we're also going to set S equal, or that 90 equal to the actual equation for S, which again is 24t minus 0.8 t squared. So now I'm in a position where I know the position. That's weird. I'm in a position where I know the actual position, which is at halfway. It's like this person throws a rock, right? Well, he throws a rock, and then halfway full. Sorry, this is a really bad example, but now we figured out on the last sample problem this is 180 meters, but now we know at halfway it's 90 meters, but we just don't know at what time. Like we knew that it was at 15 seconds that it took to get here at its maximum. We don't know how much time it took to get here at 90 meters. So this is 90 meters is equal to 24t minus 0.8t. So let's solve for t now. Oh, this looks very, very hard. Well, let's take a look at how hard this can get. Well, I have 90 is equal to 24t minus 0.8t squared. Well, let's see. I can subtract 90 from both sides. This is a maybe algebra that you didn't quite see for a long time. This is negative 0.8t squared plus 24t minus 90. Let's think back to algebra. How did you solve for these type of problems? If it was squared, I know it looks weird, but if you replace the t's with x's, right, x squared plus 24t minus 90, we can do a thing where you have to put into two binomials. Does anybody remember that? T plus something, right? Do you remember that? And then you can set that equal to 0, and then you just set one of these guys. That's how you would solve for these polynomials that have a high degree of 2. Okay, with the highest power being 2 next to its variable. Or you can use the quadratic formula. The quadratic formula, in which case that would be negative b plus or minus the square root of b squared. Yes, you do have to just know this, minus 4ac over 2a. You are an advanced level of math, so you do have to recall on old stuff like this. This is probably like one of the extensive, like the old stuff you have to recall. And then your a would be what? Negative 0.8. So b would be 24. And then c would be 90. Okay. Oh boy. And then you'd have to plug it all in here, and then you get t. A t, it's not x anymore, but it's t. T would be some value. I don't know. Okay. Or you have one more option. Okay. If you have a calculator, I would highly suggest doing it this way. Let's boot up my calculator really quick. So I'm not going to go through the quadratic formula, but if you plug in those values, you will get your answer for t. Okay. Let's clear this. Let's go to, why don't we actually clear this and plot this guy. So it's, plot this now. I rearranged this to have the highest exponent value coming first. So it's 0.08. No, I'm sorry, it's 0.8, 0.8 t, or in this case, the variable. I don't have t, but I can use x squared. Okay. Plus 24 plus 24. Again, I don't have t, but x works just the same. Minus 90. I am expecting a parabola because this is a x squared kind of thing. All right, let's see what happens here. Oh, I maybe should zoom out and see what it looks like. It doesn't look great, but oh my gosh. Oh, it is big. There it is there. Okay. I could trace along this guy, and then I just need to find out the x-intercepts here and here. Okay, because again, it's where s is equal to 0. Okay, s is equal to 0. So, and we're trying to find t. So that's another way of saying it's what you're really looking at. It's like y is equal to 0 is equal to negative 0.8 x squared plus 24t minus 90. Okay, so I know it looks kind of weird, but what I mean, why I wrote that down, the relationship would be like this. If I had an axis, this would be t and this would be s. But you're used to seeing x and y. Okay, so that's why I rewrote this whole thing as y, so it just makes a little bit more sense. Hopefully I didn't confuse you there, okay? Anyways, let's go ahead and figure out how you would do this on the graphing calculator. Oops. Okay, so let's go back on here. We would do second calc, or trace right here, but in blue it says calc. I think you'd go to, what is it? No, I don't think that's it. Oh, 0. You go up to 0. Come on. Come on, calculator. You go up to 0, where it says 0, the actual word 0. Press enter. Left bound, you're going to kind of like trap this point here. You're going to press enter. Right bound, you're going to go to the right and trap it to the right of the x coordinate. Guess, you're going to press, okay, so that's one possibility that you have. T is equal to 4.3933 seconds. And there's another possibility. So let's trace again. Let's go to the other coordinate. It's about right here. So we're going to second trace again. We're going to put 0. So this tells us where the x-intercept will be. It's to the left of this guy here. This is the point where we want. This is to the left of it. So I'm going to say enter. Right bound. So now we got to go to the right of that point. Guess, you just press enter again. And then you have another amount of seconds, 25 point, what is it? 60 seconds. You have two choices. It's either or. It's not both of these answers. I'm going to tell you right here. It's this right here. Okay. I think the book prefers it that way because you have to think of it this way. Again, the person, this is the best drawing I got so far. Ooh, ooh. Okay. Person throws the rock, right? And it reaches the height and it comes down. Reaches the height at 15 seconds. That's at 180 meters, right? Then the rock's got to come down like this eventually, okay? Like all the way down, okay? But let's blow this up a little bit. We asked for where it is halfway at 90 meters. What is the time? Well, I would say it's this 4.93 seconds because here it goes up halfway, it gets to the top. But if you think about it, as it goes down, it eventually hits another halfway mark, right? It goes up halfway and then reaches the top, and then goes down halfway and reaches the bottom, right? That's why you have this other time. That's at 25.6 seconds. I guess both are technically right. It's just I think your book says it only prefers ta-da one of the answers. Okay, so that's why it only has one. And in total, we're almost done. We're almost done. I'm so sorry. We must be very tired by now. We must be very tired by now. We got one more answer. We got one more thing to go through. Okay. You got two ways you can solve for this, kids. You got two ways, okay? At E, how long was the rock go up for? So again, the person throws the rock in the air, right, up in the moon. How long was it up in the air for? Well, if you think about it, again, its position, okay, its position, S, the height was at 180 meters, and then its position here is 0 meters, right? So if you think about it, you just set the S equal to 0 because it starts at 0 meters and then goes to 180 meters here, and then it ends at 0. So really, we want to see where it ends right here. So we're going to set 0 equal to the actual, what is it, 24t minus 0.8t squared, okay? And then you can do 0 is equal to, and then you got to solve what time, how much time. So we know here it's time equal to 0, so we know that. But here, we don't know what the time is here, okay? So, and it's a parabolic function or a quadratic function. It's got a squared here, so we'll give you two answers, up to two answers. So you just factor out t out of 24 minus 0. Oh, what is it? I'm sorry. I think I wrote that wrong. 0.8t. 0.8t. Okay. So this, in order to make this whole thing equal to 0, t on the outside would have to be 0. So that represents this guy, the rock at position of 0 meters in the beginning. So that's, and then here would be 24 minus 0.8 t is equal to 0. You add 0.8 to both sides, 0.8. So that's 24 is equal to 0.8 t. You divide both sides by 0.8. This looks familiar, but we actually have never done this calculation. And you get t is equal to 30 seconds. Okay, so that's one way of doing it. The other way is you should realize too that if this is a t squared, this is technically a parabola, but it's negative t squared, right? So it's an upside down parabola. If you think about it, at its height, this was at what? If you went back to the problem, earlier in the problem here, we found that at here we asked early in B, how long did it take the rock to reach its highest point? Well, it took me 15 seconds doing this math, right? This was at the very top of the graph, right? The guy throwing the whatever, I think you understand by now. Person throwing the rock, right? This was at 15 seconds. Well, it's a parabola, so if it's 15 seconds to go up, it's going to take another 15 seconds to go perfectly back down. It's symmetrical. This is a symmetrical shape. So 15 plus another 15 seconds, the total would be 30 seconds. The whole process of 30 seconds. So you can think of it that way too. Whatever saves you time, whatever makes more sense to you. Okay? So the answer for A is 30 seconds. All right, guys, that's it. I'm so sorry that was a very long problem, but I hope it totally makes more sense now. Okay? You guys, take care.